We're starting off with creating a table for storing feed information for chickens, right? We did that in Dia. I'm going to log in. And bring up the diagram that we were working on. Oh, that's wrong. Okay, so Dia, I'm going to open up a project. And where did I put it? I put it in, I think, my documents folder. There we go. Now you can see a little bit better. So I opened up the file. It was in my documents folder. Who thinks they've lost their stuff? Let's check out your screen. Why do you think you lost your stuff? So how'd you get yours where yours is all in one? We opened it and it looks blank. Well, you didn't put it somewhere else, did you? Documents. There's that one. Huh. But yeah, yours is like all together. I've noticed some people have theirs all together and some don't. So mine's separated. I'm not quite sure. Why that's the case. Full screen's not. So while some people have both windows linked together and some aren't. I don't know. All right. So we created a chicken feed table. We created a feed ID, brand, type, weight, description, organic, medicated, life stages. Pretty cool, huh? Maybe? No? Let's look at creating this in SQL. So go ahead and start up your Postgres database server. Go and start up DB Studio Forge. And go ahead and open a SQL on chickens. I've got several other windows I'm going to close so I don't click on the wrong one. I'll see I'm connected up here at the database section into chickens. Looking at your table that you've got diagrammed out and looking at the PowerPoint or your book. I got that downloaded. I'm creating a basic table. See if you can create that table inside the chicken database. So how would y'all do? And I need to adjust the attendance. I'll bring up DB Studio Forge here. Do you think you got the table in? Anybody else? Think you got it, Robert? Possibly. Okay, so did you start with create table? And the table name would be chicken feed. So did you get that far? So slide 4 right here. Show the create table command followed by the identifier, regular identifier. Then we show parentheses and the closing semicolon. I'm going to go and open up parentheses. I'm going to go and close the parentheses and put the semicolon in there. I'm going to tab over and space over a little bit just to make it look pretty. Now we have a feed ID, and it's my tab twice. It's numeric 4, right? Not a brand. should really uppercase. Brand was 30. I'm going to change numeric to uppercase too. It's not going to break anything if it was lowercase, but those are SQL commands, and our type, put that all lowercase. Weight was integer. Descriptions, text. Organic, not organization. Boolean can normally be abbreviated bool. I'll spell it all the way out. In life stage, you can't see the underscore because of the, or I can't on my screen because of the box around chicken feed, but regular identifiers, remember, can't have spaces in them. They can only have numbers, letters, and underscores. You've got something like that, and when you executed it, you didn't receive any errors. You likely got the table put in. I'm going to go into F5. It said it executed successfully. What's the error? After the chickens. What's the error list? You only. Why did it get to there and just quit? All the opening and closing parentheses look good. Oh, last line, number 10. I don't know why it's throwing the error at line 5, but you have bar care spelled wrong. Line 10. The V and C are right side by side. Now see if it will run and not have do F5. Everything looks good. I just retyped the comma. But I don't know. I deleted and retyped the comma. I don't know if we got a different type of comma. I'm not sure of another type of comma on the keyboard. It read that weird, so I don't know how you did that. Maybe it was a period instead of a comma, because all the other stuff is superscript instead of subscript stuff. All I can think is maybe it was a period instead of a comma. And the little red line made it where you couldn't see. Okay, Rick, too many commas. Line 9, you don't have another table or another attribute after line 9. There's comma says there's another attribute coming. So it's like, hey, where's it at? So now I went successful. Good stuff. Delete a table. Oh, this drop table. No, yeah, drop table in the name. Cool. So y'all made your first table. Now, likely this table, some of these attributes like brand doesn't go with possibly a chicken feed ID. Well, we'll see. It might. We might want to pull it out with like a brand ID or something and link it out. But for now, that's we got a table created. Cool. If we look at the table, select star from chicken feed, it's empty. So, but it's in there. And you see all the column headings, or you should. So yeah, we will need to redesign and create some more tables, but as far as right now, we create a real simple table with, we have no constraints or anything added into it. We'll get into later. This type of table we created is just a regular base table. So the most common type of table that you'd be dealing with in the SQL database in this class. On page 51 in your book, we talk about different types of tables that are defined in the SQL 2011 standard. The first one is what we just created, a regular persistent base table. Okay, screensaver went on. It's like, what happened to my screen? You have other tables. You have a system version table. It basically, if you create that type of table, it was recently defined in the SQL standard. It will keep histories of a row. You make changes to a record, a row of information, a system version table will, this always display the most recent change, but you can look back in time and look at an older version of that row to see what contents it had prior to changing. So that could be useful. You made a mistake and like, hey, what was this before? Could be a useful thing. The other three tables are temporary tables. And they all work pretty much very similar. You create them in memory, basically. They don't really exist in the actual database. When you're running certain types of code, you can create this global temporary table, and as long as you're logged into that session, we have a session into chickens right now, this little tab right here, the SQL 3 right up here. This is our session into it. We created a global temporary table, then we could continuously access it while we're logged into that session. And once we log out, it's only part of the session's memory, so it goes away. It's good for running odd reports and stuff where that you may need to pull different pieces of data from multiple tables and put it into one and run some analytics or something on it. So it's created for that, just for somebody's math calculation to run properly. They don't want to mess with the actual structure of the database, but they're thinking of some type of problem solving tool, and they need to pull some data, make a temporary table so they can run more math analytics and stuff on that. And the rest of them are very similar. The local temporary table is pretty much really similar. It's written inside what's called a module, I think. Let me read. Is that declared? Declares the module, declares the one in the module. So you have modules that are basically just chunks of SQL code pre-built. And if you open up a SQL session and load a module to run the SQL code and stuff inside that module, then that temporary table is only accessible in that session within the module. About the same thing with the declared temporary table. We're not going to do any of those beyond what we're going to cover in this class. We're just learning the basic SQL language. We're not going to do the temporary table and analytics and stuff. We're mostly look at building out the structure and doing some real basic queries of the database and manipulation of the data. This isn't first introduction class. We're not going to get into big analytic stuff. Like, yay, we don't get to work too terribly hard. Although you'll think some of the analytics we try get a little bit difficult later on. It'll be good. So that was page 51. There'll be some questions on that in the back of the chapter. There'll be a question or two on the quiz or different table types. Not too much though. We'll review exactly which ones we'll go over before the quiz. We've talked about column data types. We've used predefined data types already. We created text and float and varchar and integer. We didn't do float, sorry. But those are predefined. You can create your own data type. You can also construct data from from data that's already out there. So user-defined data types, you might create one for, monetary. But in this class, we're pretty much going to just stick with what's predefined out there. We're going to use integer, date, timestamp, stuff like that when we create. Not get too terribly complicated. The two types of data we'll deal with are characters. What are characters? It could actually be numbers. Letters, numbers, and symbols. Anything in the ASCII chart. So that's character strings. Then you run into binary string. It's still considered under like a string data type, but binary is machine language, stuff that a human's not going to really look at and understand. Have you ever tried to use Notepad and open up an executable? See a couple heads shaking yes. You see like lots of weird like blocks and hearts and smiley faces and just garbage that it looks like to you. Look, it can't really be displayed in human form. It's zeros and ones that the processor understands. So there's two different types. You've got, the character strings that you can see, the varchar, text and different stuff, clob if you want to call it clob, and like Microsoft SQL and Oracle. And then you've got binary. Then in a whole new subsection here, we've got numeric data. And what is numeric data? It's just numbers. Numeric data specifically, you can do what with? A four-letter word. Math. Yes. So your string data type can include numbers and stuff in it. Could be a mix, maybe a serial number on a computer would have letters and numbers and stuff in it. But you can't really do math with something that could potentially have letters in it. Even if the serial number was like 10034, if it's stored as a string, it'd be more difficult. You'd have to change the structure of it from string over to numeric. Because the computer will, flag things as either string. Like, I'm not supposed to do math on this. It's just supposed to be something people are reading, to numeric type, or that, yes, I can run this through the math code processor. Those are now built into the chips. Used to, you had to have a separate chip for math code processing. Way back in the day, before y'all were born. Some of y'all anyway. Robert's like, not before I was born, I remember that. Old people know that buying an extra chip to put on your motherboard so you can do math faster. Crazy stuff, I know. We've already covered some of that in our PowerPoint, the different numbers, the data types. And then we've got an interval type. That's date and time. So date and time is kind of special. It's not really looking at, say, 1/26/2022. It's actually looking at, what is the milliseconds counted from January 1st to get to this time. So storing it as that number instead of like 1/26/2022. So when you're entering stuff, it's not necessarily entering those slashes and dashes and stuff in there, there's an actual humongous number into the billions or trillions in there or higher. How many milliseconds it's been. I'm sure in the trillions now or higher. I don't want to think about it too hard, but that's date and time being stored. It's at break time. So let's go ahead and pause, take a break. So we're all back. There is a couple more data types in here. Boolean data is a data type. What's that? True or false? 0 or 1, right? So that's all it is 0 or 1 stored into the database. And then there's a data type that's not talked about yet. And that data type is null. Nothing. Cool. So what's so special about null? Nothing. It's actually takes up space. You don't put anything into a cell. There's actually a code written in there to specify there's nothing here. Because computers don't know how to deal with absolutely nothing there. You can't compare unknown or blank to blank or something like that. So when you don't put something in a cell, there's actually a little code printed in there that symbolizes for nothing. So when the computer looks at the hard drive, reads a couple of zeros and ones and goes, oh, it says there's nothing here. But there's actually zeros and ones there on the drive that said there was nothing here. So there was really something there. It makes you wonder about life, theology, like, but there's something there to say that there's nothing here. Yeah, flip open a book and you get to this blank page and they print out, this is a blank page. But you printed this is it, so it's not a blank page. I don't understand. Actually, it says this page was intentionally left blank. But it's not blank because you wrote on there. That's pretty much what null is. And don't try to overthink it too much. We'll be rocking against the tree in the forest, like, why? Why? So that's null. And they will talk about null later on because it is kind of special and weird. And when we get to querying stuff out of the database and looking for nothing, there's some special code you have to write. You have to look for something to find nothing. Very, very strange. It exists. And then we hit sequence generators. Some of you know what the heck a sequence generator is. Yes, we do get the sequence generators. And altering stuff. Let's just put something in chicken feed. So I'm going to leave select everything from chicken feed on the screen. And just a little visual proof of concept thing here. We're going to put a brand in, and only a brand. And if it met normal form, that should have an ID associated with it. We created a table with no real extra SQL rules and stuff. And we learn about insert quite later on into the semester, but there's insert into chicken feed. Brand values. The chickens are going to die. Maybe not. Who buys great value brand foods? Lucas does. That's the Walmart brand. Store brands normally cheaper. Yeah, we will study insert into at a later point in time. I'm inserting into chicken feed, the table. I specify the column that I want to insert things into. I can specify multiple columns, separated out by commas, and then the values. I would specify the values in the same order that I specify the columns in the parentheses up above. I'm only putting one thing in. If I hit F5, it should run both SQL commands. Make sure you have a semicolon at the end of your insert lines so that it knows that, okay, put great value in, and then it knows there's another command coming along called select star from chicken feed to redisplay on the screen. Go and hit F5. And what do we end up with? We have no identifier. So that's bad. Let's put feed ID and it's numeric 4. So 2222, comma. Why didn't I surround it with quotation marks, single quotes? So text is always surrounded with single quotation mark string values, numeric values. You don't surround it with anything. And remember, numeric values is what you could also do math against. And you have numeric, integer, float, real, small, big integer, decimal, things like that are numeric types. So anything like that, and looking at the field ID column, it's numeric. So I don't put single quotes. Anything where it's character or text or something like that, I would have to surround with quotation marks. So hit F5 again. And we got a row. If I hit F5 a second time, or row this time will be a third time, I guess. What do you end up with? You have 3 rows of data, right? We got some problems here. We have a blank field ID. We also have 2 field IDs, 2 tuples here, 2 rows that have the same ID in them. So that breaks normal form 1, having a unique ID for each row of data in the database. We got a problem going on. At this point, I guess, I don't know if I want to go ahead and use Visual Studio Code. Just copy and paste over into here. Yeah, I want to go ahead and show you another tool that a lot of IT, well, a lot of coding people, even IT people now, because scripting and stuff is very common in the IT field. It's terrible, but we do have to start scripting now, and writing code. Just do normal administration. Let's launch a tool called Visual Studio Code. It probably is not pinned to your start menu, but it might. You click start to see if Visual Studio Code is pinned there. If not, go ahead and use your magnifying glass and search for it, and at least pin it to your start menu as a tile for quick access. And everybody should have Visual Studio Code. Go ahead and launch it. There's a lot of launch in dark theme. I put mine in light theme. Might be a little bit easier for you to see. That appears to be PowerShell. So you probably opened up into a help window. I'm going to just open up a new file. So everybody can just go file, new file. New file, yeah. Let's save this new file. Let's save it in our Postgres portable 10.11. We'll just keep everything in there. It'll make it more portable for you. Your diagram will be in there. The SQL code here for examples and stuff will be kept in there. It'll be easier for you to just worry about copying that one folder up to OneDrive or to thumb drive or whatever. You know, carry it around with you, do some practice at home. If we keep everything in this one folder. I'm going to save the type as SQL. And feed, chicken feed, what do you want to name it? My chicken feed code, whatever. Name it, word it, you'll something similar. It'll end in .SQL. When you save it, does your little tab now show the image, the universal image of a database or data store? So that's either a symbol for a data storage or a database. Both are, you know, collection of data. Okay, good stuff. Let's recreate our, let's do create. No, it's not create or replace. Let's do chicken feed exist. Right? We created it. We could use some alter table statements, but I don't really want to do that at this point. I want to just alter at a later point in time. If you're developing a new database, it's a new project that you're working on for a company, you'll create tables. And once you've created a table and you want to, you know you're going to have to fix it, make changes later on, you drop the tables, drop table, chicken feed. Then I'll recreate the table, chicken feed. This way, if we make any changes, we copy all of that code. So you can't create a table chicken feed again because it already exists. So if you make some changes to the code and try to replay it to fix your table, it'll give an error. The relation already exists. So But if you put in drop table and you delete it and everything, all of its contents, and then you replay to create the table, it would no longer exist and it'd recreate it with your fixes. You wouldn't want to do something like this on a production system. You don't want to use the alter table commands because the production system would already contain data. This will be just the development phase, which is what we're in right now, learning and changing code up, because we don't truly have it in normal form 1 yet. We have feed ID and tab over. Can't type. Some of these are coming up in blue, like type, weight, description. You have to pay attention with your vendor implementation. If those need to be delimited, if you're going to put those as your identifiers for your attributes. Some vendor implementations actually have those reserved as keywords. Most likely Microsoft SQL Server has those reserved as keywords, since this is a Microsoft product. Life stage, or last one. Yeah. But, 20. Just to beautify it even more, I might tab everything over so it's really pretty. Supposed to be pretty. Your code should be pretty. All lined up. OCD like. You get it retyped, go ahead and try to recopy all of this. Oh, and let's go and add in the select everything from chicken feed. If you copy all this, paste it into the DB Studio Forge and execute it, it should link everything up. See if you can do that with no errors. I'm surprised, Rick. Awesome. Yay. Not really surprised. Typos are easy to do. Your error in the lower left-hand corner of your DB Studio Forge, you'll be able to click the error message and it should tell you like which line, and it might give you possibly enough description to figure out what's going on, maybe. Errors are one of the coolest things to try to understand. So drop table is underlined up there. What is your error that it's down in the lower left? Did it say chicken feed doesn't exist? Did you misspell chicken feed? Scroll up a little bit. drop table and here's the chickens database. So that's what it said, chicken feed doesn't exist. Table chicken feed, this, if I refresh, for some reason it's gone. So in that case, highlight the section that's not deleting chicken feed and use your F8 key to execute selection. See if that works. Did F8 work? Try right clicking. If F8 didn't run, right click on the highlighted text and tell it to how's execute current statement not highlighted. I've run into that before. I don't remember the fix. So
I think for me, because I already had the first grade table work actually next to my colon, so I think it executed drop table chicken feed.
yeah,
It didn't execute everything else, and then when I tried to execute it again after completing it, it came up with the error because you can already drop chicken. So that's what that. I think that's what happened on mine.
okay. That's why it's grayed out. You have to like click and you can hit F8 and it'll execute. So if you're on create table, you hit F8, it'll execute that one statement. And then you can click down here and select and hit F8. You can highlight. There's not an execute highlighted. Did that work for you?
Well, I highlighted it right with it.
Okay, did it run?
Yeah, it executed.
Did I run mine? I think so. Yeah, I ran. So notice all the data's gone. I dropped the table, which included anything the table is holding. If we drop the table structure, all of its contents would go away. And Rick is familiar with sequences, right? So you've not created a sequence. There's several different ways to create a sequence. And do I have it in my PowerPoint? I like my PowerPoint better here on the sequence. You can apply a sequence to a particular column. So you create sequence and you give it an identifier to identify that particular sequence. You can increment it by a specific amount of values. Why not just one? You're creating a unique ID for every column, increment it by one. Specify a range. What can it start at? What can it end at? And if it's going to be a sequence generator for a primary key column, you don't want it to cycle around. If it ever exhausts the sequence, you want it to fail. And then somebody needs to go investigate, why did we use more rows as our business model change, what's going on, we'll need to do maybe some alter table and change the amount of numeric values allowed into a column. So you would have a pretty big mess on your hands. You want to make sure your sequence generator has enough that you can create as many rows as would ever foreseeably be possible to put into the database. Always err on the side of like 1,000, 10,000 times larger than what it would possibly ever conceive of going. Everybody always underestimates stuff. US Able spent like millions of dollars with Dell EMC to come up with a 5-year storage plan. And they implemented a 5-year storage plan, so they have enough space to store things for 5 years. They filled it up in about like 13 months. So way underestimated, it's always a problem. What do we need to specify a sequence generator on? Which column? Feed ID. That should be our unique identifier. You're likely not going to query the database for feed ID. You might query the database for Purina foods to look at all the Purina branded foods and stuff. The idea is just to be a unique number that end users typically don't want to look at. But it's there to do normal form and link the attributes back to it, and also link that table and possibly other tables we're going to have. So we're probably going to need that feed ID if we want, say, the manufacturer's phone number and address and stuff. If we buy some feed and it killed all of our chickens because it had salmonella or something in it, we would want to be able to look that up, find in our database, how do we write a nasty note to the manufacturer and sue them, give it to our lawyer, whatever. We're thinking of doomsday scenario stuff. You always got to think of doom and gloom. Who's a positive person in the class? Anybody? Cool, fit really great. Everything's gonna end tomorrow, end of the world. Okay, what would you write between create table and drop table? Write the code to create sequence. Write what you would think we would need to do. Don't execute it yet. Write out the code. I'll give you a few minutes for that. Yep. Okay, I hear less typing. So we can see what we would do here. So create sequence. You need some type of naming convention for your sequences for your project. If you're going to develop out a database, I like to use SQ for sequence. So if I'm looking through the identifiers in the database, just listing them, and I see some SQs, I know those are sequence generator identifiers, followed by an underscore. And I like to put in the column ID, like feed ID. You might want to put in like sequence underscore chicken feed underscore feed ID or something like that to specify the table and the column name that it's going with. It depends on what you're going to be doing. In the book, it showed that you optionally can specify the data type here. I didn't specify that in the PowerPoint. It's optional to put in there, but if I wanted to, I could put in here as numeric 4 to specify the data type. That's optional. You don't have to put it. But you can put it so that it matches the same data type that feed ID. If it's an integer or if it's a numeric, or what did you put it as? And it should be one of the, numerical type numbers. But you don't have to put that. You can leave that completely out. So I do want to increment. It should default increment by 1. I like to be certain. Computers are not always smart and always do what you think they're going to do. Tell exactly increment by 1 should be a little bit safer. You can add start and stop values, but I just kind of like to put in max value. What did you put in for your max value? And what did you put in for min value? Well, let's do 1,000. That way it's guaranteed to always be 4 digits. We may go back and redo these sequence generators and increase numbers as we get more tables and stuff. We might throw in a 5th value. And we'll see why, but for now, we're just messing with this one table. We're supposed to learn how to, upgrade our code, improve it, fix it. Well, let's make a few mistakes. We want no cycle. Right. Hit F5. No. Look inside of it, hit F8. Sequence must be small integer or big integer. Okay. So I'm going to delete that. Told you it was optional. I'm going to leave it out. Now I'm going to hit F8. Why did it F8? Okay, now we're in. How to highlight it, right click, tell it to run. We created a sequence that now shows up in our database structure, stored under sequence folder, visually anyway. how they're visualizing it to us. It won't automatically be used in the table. It's just sitting there. We now have to implement it. We now have to fix our create table right here. I want to use the alter before the end of the class. But I'm going to copy this and put it into my Visual Studio Code over here. I also want to drop my sequence in case we ever next week need to redo the entire thing. Why am I dropping the sequence first? No, I need to drop it second. Order of drop can be confusing. If I attach the sequence to the table and I try to drop the sequence, it'll be telling me an error that it's already used somewhere. So if I drop the table and unlink the sequence from being used to a table, then I can drop the sequence without an error. It tries to stop you from standing on the limb and cutting it off up against the side of the tree and you falling with it. That type of scenario. You gotta be smart enough to not be on the limb you're cutting off. So cut the tree down first, then cut the limb off, you won't die. If you haven't tree cut before, well, sure, maybe you've seen cartoons of that. And it makes sense still. Down here at feed ID, we can add default. Next val, parentheses, and the name of our sequence. Generator. We got our Visual Studio Code updated. Go ahead and save it. We're not going to run this code. I want to use an alter statement just so we can say that we've at least done that today. We'll play more with creating some other tables and fixing stuff on Friday. Also, your questions in the back of the chapter. Does everybody have a book yet? Cool. So you'll have all the questions answered by Friday morning, right? We'll start going around the room and asking for, in your own words, what did you put for the questions? Then we'll tar and feather you if you can't come up with an answer. Just kidding. Okay, before we go today, we've got 8 minutes. We've run the sequence. You should refresh. You should see the sequences there. Let's apply it to this table. I'm going to delete everything here on my screen. Yeah, I'm going to delete everything on my screen right here. I'm going to use an alter table command. Alter table. We only have one table. Chicken feed. Inside that table, we want to alter column. Got to know how to spell column. And what column do we want to alter? We want to alter feed ID. And we want to set where are we at? We're on page. You want to look in your book for those that have books. It's on page 70 and 71. Shows the different type of syntax, but we're already selected the table. We selected the column we want to change. And now we want to set the column to something different. We want to set, and what did we change in here? We added default next value with sequence ID. So I want to set the change to default next value sequence ID. I'm going to hit my F5 key to execute that. So without dropping and deleting everything and destroying the table, we're able to make a change to this column. Just to show it works. You can highlight and execute that statement. You can go and execute it a couple of times if you want, if you get it typed in and watch the output. I'm not putting anything in the feed ID column, but what's happening? A default value is being put in. That default value is being pulled from the sequence generator. The sequence generator, stored separately in the database. Every time that it's called and ran, it has its own track of what number it used last. So it can keep track and know, just pull the next number out. Cool. Normal form 1. We have a unique identifier for the table, for a row. And it's pretty much destined to be unique because we're automatically generating it. I'm not going to accidentally overlap. If you're trying to manually put in numbers yourself, you could accidentally run the insert twice or forget which was the last number you used. You didn't write it down in a notepad somewhere, and we're supposed to do everything electronic now. And you can get 2 of the same IDs. The sequence generator helps with that. You can still manually put in 1001 more than once in there. We could alter the table again and fix that, but that's not what we're going to do today. That's next week. So we've got a terrible table created, but we got some practice in. Friday, let's do the review questions. We'll do some more practice on the stuff in chapter 3.